lot of what was just discussed applies to what we've been doing too. So I'm not going to spend a lot of time on the forms or anything that we're doing, but I did want to share a bit about our program at Turner. We do have a 2030 goal addressing job site carbon emissions. And then I wanted to talk a little bit about the sequencing and also the reduction strategies we've started to employ. So our 2030 goal, one thing is important to note is that this presentation is called A4 and A5, but actually we're going to include C1 in there as well, because I mean, by the nature of how we build our projects, you demolish the old structure and then you build the new one. And conceptually, it just makes sense for contractors to, it's kind of backwards. So it's like C1 measuring and then A5 measuring for contractors. So wanted to make sure that that's on our radar as well, that when we do job site carbon emissions tracking, it includes C1 as well. There's a question in the chat about what percentage of the pie we're talking about when we refer to A4 and A5. And I can't say across the board what that percentage looks like, but there are a few academic studies looking at whole building LCAs for projects. And we've kind of seen somewhere in this realm where you see very similar ratio impact from the A4 side of things as well as the A5 side of things. And compared to the A1 to A3 carbon emissions, this tends to be significantly lower, but I would kind of estimate on the realm of between those two slices of the pie, about a quarter to maybe a fifth of total carbon emissions can be attributed to that portion of the project. So what is Turner doing about it? Well, back in 2018, we set a carbon emission and water goal for ourselves. We dubbed it the 2030 goal. So basically over the next 9 years, we've committed to reducing our greenhouse gas emission and water consumption of our on-site construction operations by 50% by the year 2030. Let me see, there it goes. And so what that looks like for us is we use a program called Building OS. To Aaron's point, it doesn't really matter what program you use. You could use an Excel spreadsheet for all it matters. But we started off with this program called Building OS. Many of you may be familiar for use in permanent applications and building campuses or whatever it may be. But we use that for our job site carbon emissions. And that allows us to put all of our data kind of in the same place. So I wanted to talk about, since we've been measuring for our projects since 2018, and typically it's for projects over $10 million. So we've got quite a bit of data at this point. We found some pretty interesting stuff, and I wanted to share that with you today. So first off, one thing that's really important for contractors to be mindful of is that it's really important to be consistent with the boundaries that you set. And, a lot of contractors have just started their A5, A4 journey just recently. And I'm a little nervous because even between us contractors, even though we're all talking, we don't all have the same boundaries. So I think that's definitely an area for improvement. But I will say what Turner is using is we've conceptualized our A5 portion into two separate buckets. One of those is measuring and one of those is metering. Anybody can measure, right? You collect bills from subcontractors, or you fuel tickets from subcontractors, you use utility bills. This is not rocket science, and then you put it on a spreadsheet. We do it at a monthly resolution. And then the intent is that you can capture from shovels in ground until substantial completion, for us, anything within the job site fence, getting that total carbon and water footprint. Now metering is a little bit different. For that, we've actually placed live meters on quite a few of our projects to really understand when and how much and where utilities we're using. So we collect that data, it sends out pulses every 15 minutes telling us our consumption trends, and that gives us a lot more detail into the time and intensity of the usage. And so that's kind of how we distinguish those two things. I wanted to get into the findings really briefly, just to share kind of what we've been learning. One is that it's really important to get off of generators as soon as possible. I saw a couple of comments in the chat about this, and generators are kind of, they can make or break the energy, the carbon output of your project, depending on how much you rely on them. I have two projects here completely unrelated to each other, but in both cases, the purple bar is the carbon emissions from the diesel generators, and the green bar is when they finally got on temporary power. And you can see in both instances those carbon emissions from the generator are significantly higher from temp power. So what this really tells us is that we need to submit for temp power earlier. We need to make sure that we are sizing it correctly for the needs of our job site. And even if you do have to default to generators at some point throughout the project, there are a lot of technological solutions to generators that can lower the output of these purple bars. Another major finding is that combustion-based heating is a lot more carbon intensive than electrical. So these are two different projects. One of them is in Chicago, which is this one on the left, and one of them is in Sacramento. The one in Sacramento is about 2 times bigger. The one in Chicago used natural gas heating, and the carbon emissions are in green for that heating. And then on the right, we did electrical heating. And again, the carbon emissions associated with heating are in green for this project. So you're comparing the green bar here with the natural gas heating project to the green bar here for the electrical project. And logically, you may say, okay, well, Chicago's a lot colder than Sacramento, but still keep in mind that the project on the right is twice as large as the one in Chicago. So we are really trying to dig deep into understanding what solutions are out there for temporary heating solutions on the job site, because if you do any kind of combustion-based heating, it will blow up your carbon emissions. Another major finding is that electricity use is really high and water use actually in the commissioning phase or the turnover phase. So when you're torture testing all of your systems and running them full blast and they're not balanced and they're not set and programmed, those carbon emissions really come to bite you at the end of the project, because if you take any single month of electricity carbon emissions during that phase and you compare it to like even the total carbon emissions from electricity for the rest of the project, that single month can outdo any emissions savings that you get for electricity elsewhere. Another important finding was that we threw those meters on our project. We figured out when we were using them, and we found out that most of our carbon emissions from our electricity is happening off hours when nobody's on the job site. And so, and anecdotally, any of you have driven through a city at night, you know that those jobs lit up like a Christmas tree at night. And so really kind of challenging that status quo of us leaving our job site lights on, whether it be for security or whether it be just because somebody forgot or whatever it is, really challenging how we do that. Like, can we use occupancy sensors? Can we put it on timers? Like, you know, can we do photosensitivity or photosensitive lighting? You know, there's a lot of options out there to help get this demand a little bit lower. And then I don't think this is a surprise to anybody, but we found that our site equipment is one of the largest factors for carbon emissions on our job site. And what we do is we break down our graphics by subcontractor. So we're aware of which subcontractor is utilizing the most carbon emissions during the project. And so what we found is if you take a step back and you kind of look at the project big picture, we found that the carbon of our job site kind of looks like an M, where we have a really big jump in the beginning due to the site equipment, and it kind of goes down in the middle, and then towards the end it jumps back up during that commissioning phase. And so what this has really allowed us to do is for us to, you know, we're investing in strategies to reduce, which I'll talk about next, that we're spending our money on the right parts of the pie. You know, the first 2-3 years of this program have really helped set the baseline for us in terms of understanding where we need to focus our energy as an industry. So let's talk about reduction strategies. And I'll go through this a bit quick because I think we're probably running short on time. But the first thing to understand is that as contractors, we can't just go in saying we're going to spend a lot of money on equipment because it'll save carbon emissions. That is not how contractors receiving communication. I'm sure many of you are familiar with the triple bottom line or the three-legged stool or whatever. You probably have heard people, profit, planet fund quite a bit. We use that same approach for our own communication strategies and understanding which strategies are best to employ. But we also added a project to that because there are some benefits to the project that each project can realize by doing this. So how to communicate these wins is just as important as finding the actual strategies themselves. So to talk about those strategies, we have done quite a few pilot programs at Turner. We already have a no idling standard across our company, and we also have an all LED temp lighting policy. But looking beyond that, we're really starting to try and test out what kind of solutions make sense. And based on our findings, the solution is to electrify because our grid is going to continue increasing our renewables percentage. And we have to depend on the system that it will get to 100% renewables at some point. And once that happens, we will be carbon free. So focusing heavily on electrification, we're looking at things like hybridizing our light towers, which, believe it or not, a lot of them run on diesel, which is a huge waste of energy. You know, these hybrid boom lifts, when they go up and the person's sitting there doing 2 hours of caulk work, turn off the bottom unit. You know, hybridizing that is not a very difficult thing. You know, we have these little golf carts which zoom around the job site, and believe it or not, those are still not electrified yet. They're just golf carts, right? So figuring out how we can leverage our buying power as contractors to really kind of tackle these low-hanging fruit is really important in us transitioning the economy. But then there's this 50 horsepower and above bucket, which is really hard to tackle. I will be honest, a lot of the big manufacturers of equipment are still kind of in the early, many of them are in the early phases of R&D for that. So it's a bit of a challenge to make sure that we are setting ourselves up for a future where this is available to us. There's issues about the battery just running out, right, on us. There's issues about performance still. There's really significant issues about cost. And so I would say from a low-hanging fruit bucket, like the 50 horsepower and below category is much easier for us to tackle in the short term. But what simultaneously needs to happen is us contractors need to come together and engage with these manufacturers to make sure that the future is set up, when 2030 swings around, that this equipment is actually available and affordable for contractors to procure. Fortunately, there is progress on that. So there are a few, just in the past couple of years, there have been a lot of coalitions and reports coming out that talk about this transition. If you haven't had a chance yet to read this report by Bologna, it's awesome. It talks about the state of the industry for zero emission construction sites in 2019. Talks about how Oslo, piloted some of the first all electric construction sites in the world. So definitely a great read. It's something like 40 pages of really awesome content. There's also been a C40 coalition called the Clean Construction Coalition, which is basically, there's 5 cities, San Francisco, Budapest, Mexico City, Los Angeles, and Oslo have all committed to, by 2030, having zero emission construction sites within their city borders. And so this coalition is there to help support not only the contractors in those cities, but also, new cities that are looking to sign on as well. So this is definitely coming. So I wanted to just really quickly wrap up. In terms of what I think is needed, contractors really need to come together on this. As big as Turner is, if Turner raised our hand and said, we want all electric backhoes or whatever by 2025, these manufacturers would laugh at us. The conversation would look different if we suddenly had the top 15 contractors asking for the same thing. There is a network called the Sustainable Construction Leaders Group, which is hosted by Building Green, which is really well positioned for this kind of advocacy. But we really need to make sure that us as contractors are all kind of approaching the industry of the same voice. Another thing, whole building LCA credits and LEED currently don't reward reductions in A4 and A5. So even if there are some modeling softwares that do capture that, the whole building LCA initiative, like the incentive for that goes away. So that's low-hanging fruit. Aaron mentioned this, but different contractors have different ideas of what's included in scope 1, 2, or 3. So as far as corporate social responsibility reporting goes, us kind of formally agreeing on what is counted as scope 3 emission versus scope 1. Like, if our subcontractors are doing it on a job site for a client, is that scope 1? Is it scope 2? Is it scope 3? There's not a lot of consensus on that. So that's another low-hanging fruit. Modeling software to be more accurate on A4 and A5 emissions. I think this will happen over time, but currently they plug in data, and I'm not sure where the data comes from. But since the job site carbon emissions tracking really only started like in earnest like a year or 2 ago, I think creating that feedback is going to be really helpful to make sure that the modeling software reflects those changes. Would love to have more contractors collecting data. Not only would that be better for the industry, but it would make our lives easier if we can start setting the expectation with our subcontractors that it's just a norm amongst our industry. You know, this is just me saying this, not Turner, but I would say that having legislation help level the playing field, there's a big chicken and the eggs conversation happening right now of like, well, the legislators don't want to create regulation around it because the equipment's not there, and the equipment manufacturers don't want to create it because there's no demand. You know, having that legislation to just like have everybody come to the table and say, yes, this is going to be standard, everybody needs to prepare for this, will help make it easier for us to get this as a norm in the future. Quicker and more temp power to the job sites. If we are going to be electrifying our job site in the future, that you know, what that means is we have to have temp power day one, and we have to have enough to support an all electric fleet. And right now, the grid can't support all of that happen at the same time. So making sure that, again, from a legislative perspective, we are supporting that transition to an all electric future is going to be really important. And then, you know, having faster R&D for the over 50 horsepower equipment electrification is going to be a really big part of our ability to meet those goals in the near future. So I just wanted to wrap it up. I am currently our embodied carbon project manager, but Abby Roberts, who is also on the call, is a program manager managing our 2030 program and our job site emissions program. So if you have any questions specific to this program, I've put her link in here, and you can also ask questions in the chat and she can start answering them if we run out of time for Q&A. So thank you.